So sports engineering, many people have heard of sports science, but perhaps not sports engineering. So this was actually set up as a formal discipline in 1998 by a professor of physics who realised that some of the sort of fundamental engineering concepts like objects colliding, projectile motion, that sort of area, or material properties, became a lot more interesting when you applied them to the context of sport. Most of our research involves trying to quantify the interaction between the player and the environment. So this could be through monitoring how the player interacts with the surfaces that they're playing on, or how they interact with the equipment they're using. And what we're looking for is, can we improve the performance? So to do this, what we would do is generally film the player in the natural testing scenario. We then create a model of this, and in order to have the model, we have some of the material properties that we do from mechanical testing. Okay, so what we're doing here is we're trying to collect the kinematic parameters of the player as they interact with the football. So what we generally do is use a concept called motion analysis, where we have markers attached to the various body segments of the player. We then film the interaction, record the position of the markers during time, and from that information we can get parameters such as velocity of the foot as it comes into contact with the football. Okay, so in order for us to create an accurate model, what we need to do is identify what the material properties are for the football. So in the previous example we had a player who was kicking the football, and we saw that the ball deformed when the foot made contact. So what we want to know is how exactly is that ball deforming, and can we create a model of that deformation. So what we've got here is a compression test from a segment of a football, from which we're obtaining force and extension values. So these allow us to then input those values into a model and accurately have the correct material properties for the ball. Okay, so a mechanical test like the one we just saw will produce a graph of the results for us. We have a force against extension graph. We can then input these values into our computational model to get a nice accurate representation of the material that's used. So here we have a finite element simulation of a tennis ball impacting with a solid surface. So this model will have been created using the values that we found from the player testing and then the material properties. We can use this computer model to predict how the ball will behave under a variety of different testing scenarios.